Welcome to my channel Online Technical Mentor. In this video, we will study a combinational circuit, that is decoder. Before starting decoder, I think you all know about the encoder circuit. The data which are being encoded by an encoder will now going to be decoded by a decoder. I think you know that an encoder circuit has n output lines and 2 to the power n input lines. The number of output lines in an encoder will now be equal to the number of input lines in a decoder. So in this video, we will just concentrate on the decoder circuit only. Let's demonstrate with an example.
As we have already known that for an encoder circuit, if it has a n output, then it will have a 2 to the power n input lines. So here in my example, I have considered 4 cross 2 encoder. Now, if an encoder has a 2 output, then it will have 2 to the power 2 or 4 inputs. Now, the data which are encoded by an encoder will now going to be decoded by a decoder circuit. That's mean the output of a encoder will be now the input of a decoder. Since it has a 2 output for a 4 cross 2 encoder, so there will be a 2 input for 2 cross 4 decoder. Decoder circuit works just opposite to the encoder. You can say it is just a reverse of an encoder circuit. The decoder circuit also has its relation between its input and output. So in a decoder circuit, if there are n number of inputs, then it will have 2 to the power n number of outputs. So here in my example, I have taken 2 input decoder. That's mean there will be 2 to the power 2 or 4 input lines labeled as B0, B1, B2 and B3. Along with this input and output, I have also drawn an enable line. When the enable line is high, then the decoder is active. When the enable line is low, the decoder circuit is disabled. That's mean the output will not respond to any input. Here I will only concentrate on the decoder circuit only. So now come to the definitions of decoder. So decoder is a combinational circuit that has n input lines and maximum of 2 to the power n output lines, only one of which will be logic 1 at a time. When the decoder is enabled, the output of the decoder are nothing but the min term of n input variable lines when it is enabled. As I have already mentioned that for a decoder circuit, if there are n number of inputs, there will be 2 to the power n number of outputs. So in the above example, it is already clear that the decoder has 2 inputs. That's why it has 2 to the power 2, 4 outputs. At the same time, any one of the output will be logic high at a time. So for any given combination of input, any one of the output will become high or 1. If the enable line is low, then whatever may be your inputs, you will not get any output for that combination of input. Now let's draw the truth table of 2 cross 4 decoder. So a 2 cross 4 decoder has 2 input lines, 4 output lines and a 1 enable line. So I have written enable line as E, input as X and Y and output as B0 to B3, written from right hand side to left hand side. When enable line is 0, whatever may be the inputs, you will not get any output. So this cross means don't care condition. When enable line is 0, you don't have to care about the X and Y. You can ignore X and Y because you will not get any output. All the output will be 0. Now, when enable line is high, the input may be 0, 0, 0, 1, 1, 0 or 1, 1. So there will be 4 possibilities of X and Y. And for each combination of input, you will get a corresponding output. Since in a decoder circuit, any one of the output will be logic 1 at a time. So look at the first condition. When X and Y are 0, 0, at that time B0 is high. When the input combination is 0, 1, that's mean X is 0 and Y is 1. At that moment of time, B1 is 1. When X is 1 and Y is 0, B2 is high. When both X and Y are 1, at that time B3 will be high. So this is the truth table of a 2 cross 4 decoder. Now what you have to do, you have to derive the Boolean function from the truth table so that you can draw the logic diagram for 2 cross 4 decoder. Now look at the B0 output. So in this column, B0 is high when X and Y both are 0. That's mean B0 is high when X is 0 and Y is 0 at the same time. So just write the expression like that: B0 equal to X bar dot Y bar. So 0 is written as the invert of the corresponding variable. So X bar dot Y bar, Y dot, this is an AND operation. They are occurring at the same line or at the same time. So the expression will be X bar and Y bar. Now for the B1 output, B1 is high when X is 0 and Y is 1. So it can be written as B1 equal to X bar dot Y. Since X is in the low state, so X bar, and Y is in the high state, so you can write just simply Y. Next, B2 is high when X is 1 and Y is 0. X is 1 means you have to write like this: B2 equal to, just simply write down the X, and since Y is 0, write Y bar. And for the last output, B3. B3 is high when both X and Y are high. That's mean just write B3 equal to X dot Y. So this is your truth table of 2x4 decoder. And these are my 4 expression: B0, B1, B2 and B3. So first of all, what you have to do, you have to draw all the input lines first. So the input lines may be X, Y, X bar and Y bar, all possible combinations of X and Y. So just draw like this: X, and since I have attached a NOT gate, so this will be treated as X bar line since it is connected to a X. So this is the line for X, this is the line for X bar. Similarly, this is Y and this is Y bar, because a NOT gate is attached over here, so it will invert the Y input in this line. So these are my 4 input lines: X, X bar, Y and Y bar. And all these 4 expression has an AND gate. So you have to draw 4 AND gate in the 2x4 decoder. So now, as I have already said or shown you, that a decoder circuit may have an enable line. That's mean when this enable line is high, all the AND gate will be in an active state and it will give the output according to the XY input. But when the enable line is low, all the AND gate will produce 0 as an output. Because any one of the inputs of an AND gate becomes 0, all the output will be in a 0 state. So look at the first expression: B0 equal to X bar dot Y bar. So what you have to do, you have to draw connection from X bar and from Y bar and do the AND operation in between them. So that's mean draw a connection. That's mean you have to draw a connection from X bar line. This is an X bar line. And from the Y bar line, this is an Y bar line, and attach with the first AND gate, and you will get the B0. So for the second expression, B1 equal to X bar dot Y. So what will happen, you have to draw connection from X bar line and from simply Y lines. So this connection is from X bar line and this connection is from Y line. Next, B2 equal to X dot Y bar. That's mean draw connection from X and from Y bar line. And the last one, B3, is equal to XY. Then draw the connection from XY input only. This is the X line and this is the Y line. So this is a complete circuit of 2x4 decoder. If you understood the construction of 2x4 decoder, then you can try yourself to draw the logic diagram of 3x8 decoder and 4x16 decoder. Still, if you have any problem, please write down in the comment box or you can email me. In the next video, I will show you how to construct a 3x8 decoder with the help of 2x4 decoder. Subscribe to my channel Online Technical Mentor and press the bell icon for latest update.